Welcome to part 2 of my project. In the first video, I showed how I made a night vision camera, from a really cheap and crappy webcam, and an old flashlight. That night vision camera system worked pretty well, but did have some drawbacks that I want to address with this upgrade project. Get ready for a high definition, precision optics upgrade. Whilst my shitty, $7 VGA webcam did produce a functional infrared night vision system, there were some fairly serious issues, particularly when trying to view objects at long range. The low pixel count, low frame rate, and total absence of a telephoto zoom lens meant that the practical limit of range of the system was around 5 to 10 meters. I bought this 4K webcam on Taobao for $26. It uses a 12mm lens mount, which is the same as that crappy Gosu camera, and seems to be the standard used by webcams. This means that I can buy any zoom lens that also uses this same 12mm standard. I found this lens also on Taobao. It looks pretty good, and for a price of only $12. In this case, the dichroic infrared filter needs to be removed from the back of the lens. In some CMOS cameras, there is also an infrared filter, such as in this industrial camera unit. All of the IR filters must be removed. This is usually pretty simple. Here I just use a sharp pair of tweezers to pop the filter out. Dichroic lenses are pretty cool. I'll keep that for another project. Next, unscrew the existing lens. Be sure to keep the work area very clean when you open up the camera. Any dust that gets onto the image sensor could seriously impact the results. Then just screw the new lens into the webcam, and be sure to screw it fully into the lens mount. It is important to keep the same distance to the focal plane of the image sensor. I added a long pass filter to the front of the lens. This blocks all visible light, leaving only the infrared light behind, to be collected by the image sensor. I got this filter from AliExpress. I temporarily used blue tack to attach the long pass filter onto the front of the lens for testing. Later I will glue it into place. I pointed my new infrared camera out of the window. In daylight, you can see just how much of this wavelength of infrared light is produced by the sun, even on an overcast day. Here you can see the lens set to minimum zoom. What is interesting is how the clouds show up. To the naked eye, the structure of the clouds was not visible. This is because near-infrared light is strongly absorbed by water vapor, and so cloud structures become more visible. One important point to note is that despite this being a 4K camera unit, we will still get a lot of image noise and essentially a reduced resolution, because we are just looking for the infrared portion of the spectrum. The image sensor has red, green and blue pixels. The blue and the green pixels are now basically unused. And the amount of light that the red pixels capture is now going to be tiny, as only the infrared photons will be captured. I was just starting to test the upgraded camera when I found another lens on Taobao, a better lens. The objective lens of this optical assembly has about twice the surface area than the previous one, so will give brighter images. It also had the option to be supplied without an infrared filter. If you want to know how I converted an old LED flashlight to be an infrared light source, or you want to know the design details of the 3D printed holder, then please watch the video for part 1 of this project. There is a lot more detailed information in that video. I am just going to get straight to the results. I made a bracket that allowed me to mount both the old version and this new one, so I could directly compare their performance side by side. The old VGA camera output is shown here, and the new 4K output is shown in the larger window. Okay, let's test this sucker. I asked 2 of my children to dress up as burglars. For some reason, my 6-year-old son thinks that burglars look like Darth Vader. At 20 meters of distance, the improved optics and resolution are giving a major improvement over the previous version. By the time we get to 30 meters, the old VGA camera output is pretty useless. But our would-be burglars are still very visible to the new camera. At 50 meters, the clarity is at about the same level as the old camera was at a distance of just 5 meters. If I want to increase the distance even further, I am going to need a more powerful infrared flashlight. Anyway, that is all I have for you today. I hope you enjoyed my little video, or at least found some parts of it interesting. If you want to see more of this kind of video, you could always press the subscribe button. This is not a commercial channel, nor will it ever be, so I can say what I want, and YouTube's algorithm can go and get f***ed. Thank you for your time.